Okay, guys, here we go. Unit 13, day 1. So this unit is called derivatives. It stinks I'm not there in person to be doing this with you, but we'll do the best we can through the iPad here. Okay, so day 1 is called the difference quotient. The difference quotient, that should sound familiar to you. We did that earlier in the year, and now we're going to bring it back in this first lesson. So the first question I have for you there is to find the slope of a line connecting 2 points. So remember slope, y2 minus y1 over x2 minus x1, and we plug in and we get negative 7/5. Okay, so let's do the same thing, but let's do it with these 2 points. So first, let's understand what these 2 points are, x comma f of x. So this means I have some value x, and then I plug it in, and I get some value y, which is called f of x. Now the next one, x plus h. So I'm going to add some amount to x, and then I'm going to take that, that's going to become my new x essentially, x plus h, and then I plug that in to the y function, and that'll become my new y. Okay, so let's use the slope formula on this guy, and then I'll show you on a graph what this looks like as well. Okay, so this is going to be my, I'm just going to zoom in a little because I think it gets a little neater. This is going to be my, oh gosh. Okay, this is going to be my x1, this is going to be my y1, my x2, and my y2. And now we're just going to plug into the slope formula. So y2 minus y1 over x2 minus x1. And then we can do nothing with the top, but we can simplify the bottom. And this becomes a special formula called the difference quotient. And now I'll show you on a graph what's going on here. And you do have to try and memorize that. Okay, so the difference quotient. So like I was saying before, so let me just grab, I guess I'll just grab a little highlighter. Okay, so we have some value x, right? If I plug in the x value, I get my partner y, and we just call that f of x. Now if I move over, everybody see here, if I move over some distance of h, oh gosh, these big markers. If I move over some distance of h, right, my new point becomes x plus h, and if I plug that in, right, f of x plus h, there's my new y value. Okay, so let's see what we have here. So if I connect, right, those 2 points and I make a line, it says the difference quotient can be used to find the slope of a secant line. So remember what a secant line is from geometry? A secant line is where it hits twice. So it says we can use this difference quotient to find the slope of a secant line at any given point on a function. And then this is super important down here. Eventually, we're only going to have one point. What's going to happen is that distance, that h value is going to become 0. And this line is going to eventually become, oh, I am so bad at this big fat marker. This line is eventually going to become a tangent line. And we're going to be able to find the slope of a line with only one point, which we've never done before. This difference quotient is also used in calculus, and calculus is just the study of how things change, which makes sense here, right, because we're looking at an average rate of change. Okay, all right, so let's start up. We're going to evaluate the difference quotient, right, that's what this guy is right here. So we're going to evaluate the difference quotient using this linear function right here. So what is this going to give me? It's going to give me the slope, right, of a tangent line. But if I'm going to look at a linear function, the slope is going to be the same throughout the entire function. So it says we know the slope is what here? So the slope is 3. What I want to do is I want to use this difference quotient, which we wouldn't use it on a line because the slope is the same throughout, but I want to just use it so that you can see that this formula does actually indeed work. Okay, so here's what we're going to do. So if I want to evaluate, let's first just look over here for a second. If I wanted to evaluate at f of 2, right, for that function below, wouldn't I just sub into every place I saw an x, right? And I would wind up with -1. Well, it's the same idea, except I want to evaluate for f of x plus h. So I'm going to take x plus h and put it in every place I see an x. So it's going to become 3 times x plus h, right? Every place I see an x, I'm going to put an x plus h. Now continue, -7. Okay, now the minus sign right here is going to go right here, so minus. Now I'm subtracting off f of x, so I'm actually subtracting off the function itself. So parentheses, 3x minus 7, all over h. And now we'll just simplify. So we're going to get, and remember this is right here, when we're evaluating this, we're going to say m equals, because this is going to be the slope. Okay, so distribute 3x plus 3h minus 7, distribute your negative, -3x plus 7 over h. And now let's try to combine like terms there. And I can see that my 3x and my -3x are going to wipe out. I can see my -7 and my 7 are going to wipe out. And this is going to happen. You're going to get a lot of stuff to reduce. And I'm left with 3h over h. Simplify one more time, and look, there's my slope. My slope is indeed 3. So this difference quotient can be used to find the slope of a, well, in this case, the slope of the linear function. Okay. Now let's move on to a quadratic. But what's important about a quadratic is if I do that difference quotient, I'm not going to get one number because a quadratic is constantly changing. The slope is not the same. The rate of change is not the same throughout the entire function of a parabola. But I am going to wind up with what we're going to call the slope machine. And this little equation that we come up with is going to help us find the slope at any given point. Okay, but today we're just concentrating on evaluating with the difference quotient, so let's just go ahead and do that. Okay, so let's write down the difference quotient again. I think I'll use this space right here. Okay, so let's write it down again. Okay, every place I see an x, I'm going to put x plus h to start out. So x is being squared, so it's going to be x plus h squared plus 2 times x plus h. So that's all I did right there was just plug in x plus h every place I see an x. Okay, now I have my minus sign, right? So minus. And now I'm going to subtract off the function itself, but we have to use parentheses. And then all over h. Okay, so this is like a lot going on here. So I'm going to use some of this space up top to do the x plus h squared. I'll do that up here. Okay, so just FOIL, we get x squared plus xh, or hx doesn't matter, plus xh plus h squared. So x squared plus 2xh plus h squared. Okay, we got a little background noise. My daughter's making breakfast. X squared plus 2xh plus h squared. Okay, now I'm going to use the distributive property. plus 2x plus 2h. And now we have to distribute this negative right here. So minus x squared minus 2x. Ay, ay, ay. Okay, all over h. All right, now we're going to combine some like terms here. So let's see what we got. We got x squared and a negative x squared. We have a positive 2x and a negative 2x. And what are we left with? I think that's probably it, right? Okay, so m equals, we can go in descending order of powers if we want. So h squared plus 2xh plus 2h all over h. Okay, from here you can reduce just by dividing through by h, or I think some of you guys do like to, factor out the why isn't this working? Come on. The GCF, duh. Oh, okay. All right, so take out an h on top, and I'm left with h plus 2x plus 2. This is just one way to do it. And now you're left with your h's are gone. And this guy is called my slope machine. Notice that there's not a value this time. That's because the slope is not the same throughout, like the linear function that we just did. Okay. All right, so I'm just going to give you just a little tiny touch of what's going to happen, like in the upcoming days, okay? So let's graph, I think, okay, so I'm going to try something here. I don't know how well this is going to work. So I want to try and show you the calculator. So let me just see if this works. But I really don't want to be in this picture right now. Okay, good, there we go. All right, so I graphed this quadratic, this x squared plus 2x, right? So what I want you to do is I want you to think about, what do you think the slope might be if we went to x equals negative 3? So if I went to x equals negative 3, 1, 2, 3, x is negative 3. Let me just keep the, oh, goodness. Okay, there we go. If I went to x equals negative 3, right, and I went up and landed on this parabola, and I drew a tangent line right there, can everybody see that I would have a negative slope, and it would be pretty steep, right? It doesn't look like it would be negative 1, right? It looks like it's pretty steep at x equals negative 3. So if I go to negative 3 now, let me go back to this now. Okay, if I go to negative 3 and I were to plug it in, to this function right here, right? I would get, just ignore the h for a second, I would get negative 4. So does it seem like the slope could have been negative 4, right, of that parabola that I just graphed for you guys? I think so, right? I think the slope of that tangent line could be negative 4. So then what happens to this h? Well, let's go back to this picture here. And we're going to do this another day, but I hate like doing this and not showing you what it looks like. Let's go back to that picture I had before. Well, eventually, right, this h value right here is going to become 0. If that h value becomes 0, it means that I'm only going to have 1 point. So I'm going to have a tangent line instead of a secant line. Okay, so eventually that's what's going to happen. But today we're just practicing the difference quotient. And I just want you to understand that this value that you get right here is, or this expression that you get right here instead, is called the slope machine. Okay, and we get it by using the difference quotient. Okay, number 3 is crazy. Number 3 usually is going to be like one of those questions where I would be like, all right, go ahead, and, first couple of groups that get it, you'll get a challenge card because it's just a lot of work. So I guess we can't do that, but you guys can do it on your own. Why is this one going to be difficult? I already did it, so I don't really want to reveal all the work. I mean, I guess I could reveal a little bit. No, I'm going to keep it covered. You have it there. All right, so 4x cubed minus 5x. When you sub in, you're going to have to do x plus h cubed. So it's going to have to, 3 times you're going to have to multiply. You have to FOIL and then multiply again. All right, so go ahead, pause the video and try. See what happens. All right, here it is. So let's try and follow. So same idea. Here's my function. And I want to plug in x plus h every place I see an x, right, to start out. So that's what I did on this first line right here. Now see the blue, the x plus h cubed, that's a lot of work. So I went off to the side over here and I did that. And then I carefully distributed the negative right here, the -5, carefully distributed this negative, right? So just check out all this work. Pause the video, check it out. You just have to carefully do it. There's my slope machine. Okay, we got one more to do. We'll do this guy together if you want, or you can go ahead and do it yourself. Okay, so we'll write down the formula again. The difference quotient, which is going to give us the slope machine, which will give us the slope of the tangent line at any given point. Okay, that's what this is all about. And we've never done that before. We've only done slope when we have 2 points. So this is allowing us to find what's called the instantaneous rate of change. But we'll get into that in the next few days. Okay. Okay, so here we go. Let's plug in. Sorry, I didn't mean to take that away. Okay, so every place I see an x, now I'm going to put x plus h. So this is going to be 1 over x plus h minus the function itself, and then all over h. Okay, so we can see that this turned into, top bottom, if you want to organize it like that, like how we've been doing it in class, or however else you want to solve it is fine too. So we have 1 over x plus h. Actually, no, let's not do that. It's only an h, so let's just simplify the top. A little easier. All right, so let's just get an LCD for the top. So the LCD for the top is x and x plus h. So I'll multiply by x, I'll multiply by x, I'll multiply by x plus h, I'll multiply by x plus h. So I'm left with x, and now I have to distribute on top there, right? So x minus h over x times x plus h. And now that whole thing, we can't forget, is over h, right? Okay, let's simplify. So these guys are gone. So I'm left with negative h over x plus h, all over h. And now here's where you could do a little top bottom, but we really didn't need to make the chart because it's not so complicated. So keep the top and multiply by the reciprocal of the bottom. Now remember, this is h over 1, so the reciprocal is 1 over h. H's are gone, and I'm left with negative 1 over x times x plus h, and this is my slope machine. Okay, this will allow us in the future to find the slope of a tangent line of 1 over x at any given x value. Okay? All right, guys, so we'll pause there, and it looks like the homework is 1 and 2 on the next page, page 4. So there it is right there. Okay, so you guys go ahead and do that. All right, till next time, bye.